Greetings everyone. Today we are going to see modulo multiplicative inverse, how to compute B inverse mod M using extended Euclidean algorithm. Here we will be seeing an example with an examples how to apply extended Euclidean algorithm to compute B inverse mod M. For B inverse mod M to exist, GCD of B comma M should always be equal to 1. So let us compute some example. Let's see with an example. So 3 inverse mod 7, 3x is congruent to 1 mod 7. So before that, what is multiplicative inverse? Multiplicative inverse, in a sense, for example, you have got a number like 3 by 4. Sorry, ma. It's 3 by 4. So what will be the? So you got a number 3 by 3, or you got a number 3 and 3 by 4. Multiplicative inverse of it is going to be 4 by 3, because 3 by 4 into 4 by 3 is equal to 1, right? So reciprocal of 3 by 4 is going to be the multiplicative inverse. So multiplicative inverse of 3 by 4 inverse is going to be 4 by 3. So when we multiply both this 3 by 4 into 4 by 3, we will get 1. Similarly, for modulo multiplication, we have 3x is congruent to 1 mod 7. That means x is congruent to 3 inverse mod 7. We have to compute these values, and this can be computed using this way, right? For example, we should go for, first of all, we go for you have to fill up the, initially it will be empty, Q will be empty, and A1 will be 1, and A2 will be 0, A3 will be B inverse mod M, means M will be, take the A3, and 0, 1, B is 3, right? Now we have to divide A3 divided by B3. 7 divided by 3 is 2, right? So 2, and the remainder goes on the B3 side. We shall do that. 3 2s are 6, remainder is 1, right? So we will walk through 0. We'll copy B1, B2, B3 as such in A1, A2, A3, and then we'll compute A1 minus Q B1. A1 minus Q into B1. So 1 minus 2 into 0. So what we have to do? 1 minus 2 into 0. That will be equal to 1, right? So now 0 minus 2 into 1 is minus 2. So when B3 is 1, that is GCD is equal to 1, right? GCD is equal to 1. We have written B2, so minus 2. So your answer for the corresponding this one is x is equal to minus 2. So that means 3 inverse mod 7 is equal to minus 2 mod 7 is equal to minus 2 mod 7. Minus 2 mod 7 minus 2 mod 7 is equal to minus 2 mod 7, which is equal to 5 mod 7. Which is equal to 5 mod 7. Equal to 5. So your answer will be 5 mod 7. 5 or 5, right? Do 5. X is equal to 5. So you can calculate that. 3 into 5 is 15. 15 divided by 7 is 7 2s are 14. You have got a remainder 1. So 3 into 5. So 3x 3 inverse mod 7 is equal to 3 inverse mod 7 equal to 5. Yeah, it's equal to 5. So similarly, we shall see some other examples. So shall see some other examples. Right. This is some more examples wherein which we will do some computations. We should see some more examples. So here we will see 3 inverse mod 17, right? So 3 inverse mod 7 is 5, right? And now 2021 inverse, so it will be somewhat bigger. 21 inverse mod 4032. We shall see these also. 4032. It means, what does it imply? 2021 into x is equal to 1 mod 4032. Equal to 1 mod 4032, right? So when you multiply anything by 2021, it should result in, and divide by 4032, it should result in the remainder as 1. X is equal to 2021 inverse mod 432. That we have to compute. So we should start with this one. So initially it will be Q will be empty, and now we will have 1 0 1 0, and then A3 will be M, right? M is equal to 4032, and 0 1 2 0 2 1, right? We shall find so A3 divided by B3 is equal to 2021. Ones are 2021, and remainder is going to be 2011. And then now we should remove this marker, and then now we will have 0 1. We have to this one 0 1 2 2021. We will copy this. So now we shall have A1 minus Q1. 1 minus 1 into 0 is 1 only, and 0 minus 1 into 1 is minus 1, right? We should do this also. And now 2011, ones are 2011, and we will have 10 will be our remainder. So we shall copy 1 minus 1 2011, and we will have 0 minus 1 into 1 is minus 1. 1 plus 1 is 2, right? This could be 2, right? So now 2010, so 201 quotient, you will have 1 as remainder, and then now minus 1 copy from B1 B2 B3 2 and 10, right? Then we shall have this, right? How will you do? A1 minus QB1, 1 minus 201 into minus 1. 1 plus 201 is 202. And B2 will be your answer. 1 in minus 201 into 2. So going to be minus 1 minus 202 will be minus 403. So your answer is minus 403. Your x is equal to minus 403. So we shall write down x is equal to minus 403. X is equal to minus 403 mod 4032. Minus 403 mod 4032, which is equal to 4032 minus 403 equal to 3629 mod 4032. So this one you can check if you want. You can check. The answer is going to be x is going to be 3629 or minus 403. So x is going to be 3629. So 2021 into 3629 you have to do, and we can check. It will be divided by 4032. It will be 1 as give 1 as remainder. The next question, we shall see some more examples. We will fill with some more examples, and last some exercises which should be done. So we shall ask some exercises to be done. So we shall find some more examples, right? So we shall do it in this one. So please you try these examples. 15 inverse, 15 inverse, mod 26. So 15 inverse mod 26, right? Mod 26. So try these examples, and these examples to find examples. Try these 15 inverse mod 26. It's in the form B inverse mod M. For B inverse mod M to exist, you should have GCD of B comma M should be equal to 1, right? So just check that also. So 3 inverse mod 17. 3 inverse mod 17. You can try these examples. 3 inverse mod 17. 5 inverse mod 14. So try these examples. 20 inverse mod 3, 14 inverse mod 7. 20 inverse mod 3, right? 20 inverse mod 3. 20 inverse mod 3. Some examples you can try. It's 40 inverse mod 7. And I got the answers for these also in the previous video. So you can try this example, and so you have written B2. This is B2 one you have written. B2. This one you have written. When B3 is 1, you have written B2. When GCD of B comma M is equal to 1. Find B inverse mod M. It's in the form of B inverse mod M, and this one, right? Thank you very much. You have got something about the Euclidean algorithm, right?